Hey everyone, if you've been enjoying my free math lessons on Prodigy Mathematics, I've got a great way you can support the channel and supercharge your learning. I've launched Martian Mathematics, a growing collection of problem sets, quizzes, and fully worked out solutions designed to complement my videos. These aren't just generic worksheets. Each set follows my lesson structure, reinforcing key concepts with carefully crafted problems and step-by-step solutions. Every purchase helps keep this channel running, so I can continue bringing you high-quality, free math education. Check out Martian Mathematics on Teachers Pay Teachers today. Your support makes all the difference. And don't forget to like and subscribe. Welcome to Lecture 15 on negative numbers. So let me start by asking a question. What is 2 minus 5? Now you'd say, well, if I have 2 cookies and I try to take away 5 cookies, I don't have enough cookies to take away 5 cookies, do I? So that's basically what we're going to be exploring in this lecture. And one of the tools that we're going to use to understand negative numbers is the number line. So what is a number line? Well, imagine that I have a ruler laid out, and we could number this thing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I want to introduce a new kind of number called a negative number. Now, how are we going to do that? Well, what I'm going to do is instead of having 0 over here, that'd be the start of the ruler, I'm going to put it right here. So this is my 0. And then going to the right, I'll count forward as usual. This would be 1, and 2, and 3, and 4, and 5. But going in the opposite direction, we're going to do basically the same thing, but we're going to use this new negative number. Minus 1, minus 2, minus 3, minus 4. And over here at 0 would be minus 5. And I'm also going to introduce, because it is a ruler, rulers measure distance. And distances are always, or lengths rather, are always positive numbers. You cannot say that you have a car that is negative 10 feet long. That doesn't make any sense. And so mathematically, what we can use to represent this kind of measurement of length is something called the absolute value. And we denote it with 2 vertical bars, and we put a number inside. So for example, the absolute value of 3 is just 3. Whereas the absolute value of minus 3 would also be 3. Now what does that mean? Well, if I think of the first one, I would put a little, actually I have a dot. I can use these finally. If I put a point here at 3 on the number line, the absolute value of 3 means that is the length or the distance from the origin, 0, to the point. So if I laid out a ruler and measured this distance, it would measure 3 units long. Similarly, if I were to place the point at minus 3 and using the same ruler measure the distance, you can see the distance is the same. It's also 3 units long. So, because that's what rulers do. They always measure positive numbers for us, yes? We call them lengths. Let's use this number line to explore how we can do arithmetic on it. So let's say that I have the problem 3 plus 2. Well, how am I going to interpret that? Well, what I suggest is thinking of this as kind of a starting point, 3. So we'll put our point here at 3, and then it says move 2 units to the right. So we're going to think of the plus, the positive direction, to the right. See that? That is the direction of kind of increasing value, you see? So 3 plus 2 means start at the point 3 and move 2 units to the right. So if I do that, I go 1 unit, and then 2 units, and I find myself at 5. And so we can say that 3 plus 2 equals 5, which of course makes sense with what we already know about adding positive numbers, yes? What if I change the sign on this and I say, well, I want to do 3 minus 2? Well, again, we would start out at 3. And the way to interpret this is the negative direction. Well, if that's the positive direction, which way do you think the negative direction is? Yes, this way, exactly. You could say to the left. That would be fine. So we start at 3, and we move 2 units to the left. 1, 2. And we find ourselves at 1. And so does 3 minus 2 equal 1? Yes. Yes. And so we see that this works with our understanding of basic subtraction. Now, I said these are negative numbers. And so how do we interpret something like this? Let's do minus 2 plus 3. Well, that would tell me, if I use the same prescription that I used before, that I should start at minus 2 and move 3 units to the right. 1, 2, 3. And I get to 1. Well, that seems familiar. And it is familiar because of something called the Associative law of arithmetic. So what does that tell us? Well, it tells us that 3 minus 2 is the same thing as minus 2 plus 3. I'm allowed to switch the order in which these appear, you see? Now, maybe it makes more sense if you were to think of a simpler problem like 3 plus 2 equals 2 plus 3. Yes? If I start with 3 cookies and I get 2 more, I have the same number of cookies as I would if I had started with 2 cookies and you were given 3 more. Now what I want to do is I want to think of these signed numbers, because you look here, you're like, well, how was I said to start at minus 2. And then when I did this problem, I said we're going to start at 3 and move 2 to the left. So it's almost as if there's some positional importance in what the negative sign means in these cases. So I want to kind of disambiguate that by putting the number in parentheses. I want to write 3 minus 2 as 3 plus minus 2. So this is what I mean by a signed number. The sign is no longer really the operation, you see? And so that's what allows me to rewrite this as minus 2 plus 3, because we're really thinking of minus 2 as a signed number. And if that's our starting position, it just simply means that we start at that number. Yes? But if it was in this position, it would mean that we're going to go 2 units, but to the left, because that gives us the direction, you see? I know it can get a little confusing, but we'll get through this. Now, I really want to get to answering the question at the beginning, what does 2 minus 5 mean? Let us note that 5 is greater than 2. Everyone agrees with that, yes?
Yes.
And what does that mean on the number line? Well, it means that if I compare the points 5 and the point 2, the point 5 is farther to the right. And that's what we mean by 5 is greater than 2. Similarly, we could write that 2 is less than 5. And that would mean that the point 5 and the point 2 is further to the left than 5. Well, let's do one more comparison. I would like to compare the point minus 2 and the point 5. Here's minus 2. Here is 5. Is 5 to the right of minus 2?
Yes.
Yes, it is, which means that minus 2 is less than 5. Similarly, we could write that 5 is greater than minus 2. Does that make sense?
Yeah.
So now you understand what we mean by less than and greater than in terms of points on a number line. Now, let's take our original problem of 2 minus 5 and interpret it a little bit differently, say in terms of money. But first, let me ask you a question. Which would you prefer, $10 or $100?
100.
Why would you prefer $100?
Because it's more money.
Because it's more. It's greater than, yes?
Yes.
So as a general rule of thumb, one of the basic underlying tenets of economics is that people prefer more money than less. And so if I think of dollars now as, would you prefer negative $2 or $5? Well, since negative 2 is less than 5, and therefore 5 is greater than negative 2, I would prefer $5. And so the way that we think about that is having $5, and it would be what we call the positive 5, right? The negative 2 would be what we would call debt. That means you owe. So not only do you have no money, but you owe somebody $2, you see? So you would rather have $5 than owe $2. Yes? So let's look at that original problem. I think I mixed up which one I had. I think I had minus 5 and 2. So what I meant to say was, would you rather have minus $5 or $2?
2.
2 because it's more, it's greater, right? Even though the magnitude, right, the absolute value of 5 or minus 5 and the absolute value of 2, the 5 is a bigger absolute value number, yes? But it's way over here, way to the left, which means that you are in debt or in the hole, as they say, yes? So the original question that I opened the lecture with was, what is 2 minus 5? And so using the method that we developed here with the number line, that says to start at the point 2 and move 5 units. We can think of this as plus minus 5, if you like. Start at the point 2 and move 5 units to the left. 1, 2, 3, 4, 5. So the answer to our question is that 2 plus minus 5 is equal to minus 3. Make sense?
Yes.
Let's consider the problem 11 minus 12, which is also 11 plus negative 12, if you like. Now, my number line is not quite big enough. I'd have to draw kind of a broken number line to really consider this. You have a break. So you say this is at, put the 0 here, put the 1 here, and then we'll maybe start up again at 10, and then at 11, go to 12 maybe. This says to start at 11 and move to the left 12 units. But what happens if we only move 11 units to the left? So what is 11 minus 11? 0. We find ourselves at the origin, right? Because if we move that full 11 units, we've moved this full span here, yes? And how much more do we have to go? We were supposed to move 12 units to the left, but we've moved 11 now, right?
Yes.
So we have 1 more to go, right? So how much more do we have to go? Well, that is 12 minus 11 is how much more we have to go, and that's just 1 more unit, yes? Because we're supposed to move 12, and we've already moved 11, yes?
Yeah.
I don't really need the absolute value here. I'm not sure why I wrote that, sorry. And so this gives us a kind of a trick that we can use to do these kind of problems a little more easily. It tells us that we can rewrite a problem like 11 minus 12 as a negative sign of 12 minus 11. You see? Because we know, because 12 is a negative number and it's bigger than 11, that we're going to be in negative territory. Because if we only move 11, we're at 0, and we still have more to go. So we're going to be, our answer will be a negative number. And so the trick that we can do is we can kind of reverse this, turn it into 12 minus 11, but make sure we put a negative sign on it at the end. So what is 12 minus 11?
Negative 1.
No, 12 minus 11 is just 1. But when we put the negative sign on it, we get minus 1. And that's where we would find ourselves on that number line, which unfortunately I erased. But I want you to remember the way that I wrote this with the parentheses, because we're going to come back to that later and interpret that a little bit different. For now, all I want you to think of is, don't forget to put a negative sign on this. Why? Because the 12, which is the larger magnitude number, that means its absolute value is bigger, right? Has a negative sign in front of it. And it's bigger than, the magnitude of negative 12 is bigger than the magnitude of 11. Therefore, we're going to have an answer which is negative, yes? Does that make sense? So when we see 11 minus 12, the first thing we should think in our head is, well, it's going to be a negative number answer, okay? And what the actual answer is going to be negative 12 minus 11. So far we've dealt with mixed arithmetic, where we have a positive number and a negative number. Well, you know what happens if we only have positive numbers. If I said 2 plus 3, it's 5, right? We start at 2, we move 3 to the right, we get 5, yes? So when we do arithmetic with positive numbers, when we add positive numbers, we'll get a positive number. And we saw that when we do arithmetic with a positive and a negative number, if the negative number has the larger magnitude or absolute value, then it will be a negative number answer. If the positive number has the largest absolute value, then we'll have a positive answer. For example, 12 minus 11 would be plus 1 or positive 1. Whereas 11 minus 12, since the 12 is the bigger magnitude, will be a negative answer, negative 1. Okay? But what happens if we're adding two negative numbers? So how about minus 2 minus 3, which is also minus 2 plus negative 3, if you'd like. Well, what does it tell us to do? Well, we can just interpret it like we did before. It would say start at minus 2 and move 3 units to the left. 1, 2, 3. And that gives us minus 5. Well, that's interesting because it looks like we just simply added, doesn't it? Because 2 plus 3 is 5, but it's a negative 5, you see? So the trick to dealing with adding negative numbers, since we start in negative territory and we only move to the left, our answer is going to be negative. But basically it is addition. So you can think of this, minus 2 minus 3 is equal to minus 2 plus 3. Now there's a useful analogy, I think it comes from James Tanton of the Mathematical Association of America. It's called posts and holes. So when I was a kid, my grandfather used to be a bit of a jokester, and he was a rancher, and he came in one day with a big trailer behind his pickup truck, and I asked him what was in the trailer, and he said, it's full of post holes. I was like, oh, that's interesting. What does that look like? So I went up there, I looked in the trailer, there's nothing in it. He meant the trailer was empty. So a post hole and a fence post, they're kind of the opposite of one another. And so you imagine a negative number as a hole, like this, and you imagine a positive number, so this is a negative number, and you imagine a positive number as a post. And so if I have a problem like, let's say, minus 4 plus 3. Well, this says you've got 4 holes and 3 posts. And when we add these together, and there is no such thing as subtraction, you're always adding them together, then you have, here's my 4 holes, and I'm going to add my 3 posts, and I'm going to do it by starting here. I put the post in the hole, that basically fills the hole, and I have nothing. It's gone. It's annihilated, if you will. I still have 2 more posts to put in, so I put in another. That annihilates this hole, and so I have nothing. And then I add the last post to the hole here, annihilating it. I'm left with 1 hole as an answer. And so minus 4 plus 3 is equal to minus 1. If I added only negative, if I had like minus 4 minus 3, I'd have just drawn 3 more holes, and I've counted up the number of holes that I have and said I've got minus 7 holes, or negative 7. So sometimes when working with the addition and subtraction problems with negative numbers, it's useful to use this post-hole analogy. So let's summarize what we're going to call rules for adding and subtracting positive and negative numbers. And so we have that a positive plus a positive is equal to a positive. Similarly, we have that a negative plus a negative is equal to a negative. Right? Because if we start in negative territory and we only move to the left, we'll still be in negative territory, so we'll have a negative number. And then finally, if we have a positive plus a negative, which is also could be negative plus a positive, the order doesn't matter because of the associative property, this depends, right? If the absolute value of the positive number is greater than the absolute value of the negative number, that is the distance they are from the origin, then we're going to get a positive number. Whereas if the negative number, the absolute value of the negative number is greater than the absolute value of the positive number, then we will get a negative answer. And so those are basically our rules for adding and subtracting signed numbers. Let me give you a couple to try to make sure that you understand these. Maybe I'll leave the rules up here for you. Minus 7 plus minus 10. So go ahead and pause the video. I'll leave the rules up here for you to see. Give that a try at home. Come back when you've got your answer. Well, we look at our rules, we see we have a negative number and a negative number, right? So negative plus negative is a negative number. We know our answer is going to be negative. And we might remember that we just simply add the 2 parts. So this is just negative 7 plus 10 which is minus 17. So if I had 7 post holes and 10 post holes and added them together, I'd have 17 post holes, you see? Okay. Let me give you another. Minus 18 plus 4. So go ahead and pause the video. Try that now. Come back when you have your answer. So here we have a negative number plus a positive number. So we're going to use this rule here, rule number 3, I guess it is. And so the question we have to ask is, the absolute value of the negative number, is that greater than the absolute value of the positive number, or vice versa? And we see that the absolute value of minus 18, which is 18, is bigger than the absolute value of plus 4, which is 4. Therefore, we're going to have a negative number answer. So we can go ahead and put the sign on here. Now, because it is a difference, though, we do have to take a difference, and we can just do the absolute value of 18 minus 4. Or, well, just do 18 minus 4. And what is 18 minus 4?
14.
14. But it's got a negative sign, so it's negative 14. Not too bad, huh?
What's the problem?
Negative 18 plus 4. Yes?
Then why is it a 22?
Well, because if we were to go, we would start at negative 18, right? So let's just draw a number line. Here's minus 18, minus 17, minus 16, minus 15, minus 14. We start at negative 18, and we move 4 units to the right. 1, 2, 3, 4. And here I land at negative 14. I think the way that I explained it before was I would have said, okay, let's just reverse the order of these. We can do that because of the associative property, and think of this as 4 minus 18, right? And I said, okay, well, we start out at 4, and we're going to move to the left because we're subtracting, yes? And if I go 4 whole units to the left, I'm at the origin. I'm at 0, right? And the question is, how much more do I have to go? Well, what is 18 minus 4? I need to go 18 moves. I already did 4, so 18 minus 4 is 14. But I know I'm moving to the left, so I'm going to be in the negative number area of the number line, right? So we just take the difference, 18 minus 4, and we put down a negative number sign in front of it, okay? Okay. A lot of people have trouble with negative numbers, okay? I knew somebody that tutored somebody in college that had problems with negative numbers. They just didn't get it. So you have to take your time with it, make sure you understand it. But you can always fall back on the number line, right? Start here, move 4 to the right. Start here, move 18 to the left. It's the same thing. So now let's move on to multiplication of negative numbers. So what could this possibly mean? 3 times negative 2. If you think about multiplication properly, then you think of this as the number 3 taken negative 2 times. And that doesn't make any sense to us. I don't know how to do something a negative number of times. Fortunately, we also have, we talked about the associative property for addition earlier, but there's also an associative property for multiplication. So that means that A times B, where A and B are just any old numbers, is the same thing as B times A. So you can, take an example. 2 times 3 is the same thing as 3 times 2. So taking advantage of the associative property, I can simply rewrite this 3 times negative 2 as negative 2 times 3. Notice that I leave the parentheses off when I have the negative number leading. The reason I put it here is to kind of disconnect it from this operation sign here. This is an operation, whereas this is the sign. If there's no operation in front of a number, then you interpret this as just the sign. This, believe it or not, I can make sense of. It says, take negative 2 and add it to itself 3 times. Well, that's not hard. We can do that. Negative 2 plus negative 2 plus negative 2. And if you like, you can think of this as 2 holes plus 2 holes plus 2 holes. How many holes?
6.
6 holes. 6 holes. So negative 2 times 3 is just -6. Yeah?
Yes.
Make sense? Now, unfortunately, I cannot make any sense whatsoever of a negative number times a negative number, because no matter what I do, I still have to do something a negative number of times. So if I said, well, if I had -3 times -2, switching the order isn't going to make any difference, right? I still have to do something a negative number of times, and we don't know how to deal with that. We don't know how to explain that in a way that is meaningful or makes some kind of sense. So we'll take a different approach. But first, I want to explore a couple of little ideas here. First, let's try a really easy problem, shall we? What if I did -1 times 5? It's not hard, is it? What is -1 times 5? What is 1 times 5?
5.
It's 5. So what is -1 times 5?
Minus.
-5. That means I take -1 and I add it 5 times. We got 5 holes. 1, 2, 3, 4, 5 is the answer. 5 holes. So it's equal to -5. So the reason I wrote this very simple problem is to point out that when you see a negative sign on a number, what a signed number is, it can be interpreted as meaning -5 is the same thing as -1 times +5. We say that we factor out a -1. So you can interpret the negative sign in front of a number as being -1 times that number. Now, why is that useful? Well, because if I take a problem like I was doing before, where I said, let's do -3 times -2, well, let's factor it. Let's break it down into all the factors that it has. So we know that -3, for example, is equal to -1 times 3. So I can rewrite this as -1 times 3. Similarly, -2 is equal to -1 times 2 times -1 times 2. Now, why is that useful? Well, because I can rearrange, because again, we have an associative property for multiplication too. It doesn't matter the order that you do it in, right? So I can rearrange these numbers. I can move the 2 around, the 3 around, whatever. I can also regroup these parentheses. I can say this is the same thing as -1 times -1 times 3 times 2. It's just the associative property. I first recognize that -3 means -1 times 3, and -2 means -1 times 2. And then I use the associative property to just group the minus sign problem together and the positive sign problem together. Now, I know how to do 3 times 2. That's 6. All that's left is to deal with this -1 times -1 business. This part is just 6. This part is what we don't know yet. Well, fortunately, we can prove it. Now, this is not a proof-based course. This is basic arithmetic that we're doing here, the fundamentals of mathematics. But there's no harm in having a little proof, and it's really the only way to show you what this does. There's one more thing I have to add. It's another property of arithmetic. It's called the distributive property. It's pretty easy. It says this. It says that A times B plus C is equal to A times B plus A times C. And usually the way people think of it is they think, okay, this gets multiplied by this and by this. So, for example, if I said, what is 2 times, and I put in parentheses, 2 plus 3? Well, I know that 2 plus 3 is 5, and 2 times 5 is 10, so I know the answer should be 10, correct? But let's use this distributive property. We'll do 2 times 2 plus 2 times 3. And what is that equal to? Well, 2 times 2 is 4, and 2 times 3 is 6. And what is 4 plus 6? That is equal to 10. So when you break a number like 5 up into 2 pieces, it's called a binomial expression. It means it has 2 terms in it, you see, the 2 and the 3. So you can write 5 as 2 plus 3, and since I can multiply 2 times 5 freely, I can also multiply 2 times 2 plus 3 freely. Yeah? So we'll need this distributive property in order to prove, or derive, if you will, what -1 times -1 is equal to. It's going to determine the sign of this answer. We know its magnitude, or its absolute value, will be 6, -3 times -2, but we don't yet know what the sign is going to be. So let's find out. 1 minus 1, what's that equal to?
0.
0. Everyone agrees with that, yes?
Yeah.
Now, I'd like to multiply both the left and the right side of this equation by a -1. After all, we know how to do that, right? So I'm going to put some parentheses on here because I'm going to multiply this whole thing times minus 1. So I have minus 1 times everything in parentheses. And what is 0 times minus 1? What is anything times 0?
0.
0. Now I'm going to use the distributive property, which I just showed you, to carry out this multiplication on this binomial term here. So I'll first multiply minus 1 times this positive 1, minus 1 times 1. And then I'm going to take minus 1 times minus 1. Minus 1 times minus 1. I'm going to put that in parentheses too. Still equal to 0. Well, what is minus 1 times 1? We already know how to do those kind of problems. Who can tell me the answer? What is minus 1 times 1?
Minus 1.
Minus 1. So this simplifies to minus 1 plus minus 1 times minus 1 equals 0 still. Now if I were to add 1 to both sides, what happens? Let's go up over here. I would have minus 1 plus 1 plus minus 1 times minus 1 equals 0 plus 1. Because I added 1 to both sides.
Yes.
Well, the right side is easy. 0 plus 1 is just 1.
Yes.
Now what is minus 1 plus 1? It's 0. This goes to 0. And so I'm left with minus 1 times minus 1 is equal to positive 1. And so now I know what the answer to minus 1 times minus 1 is. Apparently it's a positive. Which means that minus 3 times minus 2 is minus 6. So here we can say, oh, this means minus. Oh, sorry, means plus. Yeah. So let's summarize the rules for multiplication. So call it multiplication rules. Well, a positive times a positive is equal to a positive, just like before. But interestingly, as we just found, a negative times a negative is also equal to a positive. And finally, a positive times a negative, which is also the same thing as a negative times a positive, is equal to a negative. So if you multiply two positive numbers, you'll have a positive number answer, product. If you multiply two negative numbers, you'll have a positive number product also. If you multiply a positive number times a negative number, or a negative number times a positive number, you'll have a negative product. And those are basically the rules for adding, subtracting, and multiplying signed numbers. Now what about division? Well, as it turns out, the division rules, because division is related to multiplication. Remember that we didn't have separate rules for addition and subtraction. We said adding signed numbers, right? So basically the rules for division are the same as the rules for multiplication. So if we had a positive divided by a positive, or a negative divided by a negative, in both cases the answer would be a positive number. And if we have a positive divided by a negative, or a negative divided by a positive, now in this case, don't think that there's an associative property for division, right? 4 divided by 2 is not the same thing as 2 divided by 4. You can't switch numerator and denominator. But in any case, this is equal to a negative. So the only way you get a negative number in multiplication or division is if one of the terms that you're multiplying or dividing is negative and the other is positive, or vice versa. So let me just give you a couple of problems to try to make sure you, well, I shouldn't have erased that. Let me rewrite it. You try minus 24 divided by minus 2. So go ahead and pause the video, try that now, come back when you have your answer. Okay. Well, a negative divided by a negative by our rule is going to be what?
Equals positive.
It's going to be a positive. So we're going to have a positive sign on this. And then it's just reduced to what is 24 divided by 2?
22.
22? 24 divided by 2 is 22? 12. 12. Positive 12. We usually don't write the positive sign. You can if you want, but most people don't. Good. Let's try one more. Minus 36 divided by 18. So pause the video, try that one now, come back when you have your answer. Well, what's the rule say? That's a negative divided by a positive, so it's going to be what?
Minus.
The negative answer, right? So we're going to have a negative sign for our quotient here. Now, what is 36 divided by 18? Anyone know? Yeah, it's 2. Because 18 times 2 is 36. So the answer is negative 2. 18 goes into negative 36, negative 2 times. Which, when you say it that way, it sounds kind of meaningless, but here's what it is. I think we've covered everything. Any questions? Points of confusion? Okay. Well, that is it for this lecture. I honestly don't remember what the next lecture is on, but I'll make sure to put it in the video description or overlay it on the screen what the next lecture will be. So thank you for watching. See you next time.